Hello everyone and welcome to a Dash Enterprise video. This video is going to be focused on background tasks and caching, which could be used to automate a way of storing and retrieving data or to schedule it in a manner to make sure that your data is always up to date. So this can be used in conjunction to improve the user experience dramatically as large data sets take a lot of time to load and as background callbacks are used in a manner to help clean up that redundance in time. With this, I created this interactive documentation and like notebook to kind of explore this topic and to show the different options that you have to tackle, background tasks and caching. So with that, there are two approaches. There's the Dash Enterprise Scheduler, or alternatively, you can use a system that is set up with Redis, with Celery, and you can extend it to also include a Postgres database so that you can store the data indefinitely. So, with that, let's kind of talk about the pros and cons and kind of explore each of these different options. We'll start with the Plotly Dash Enterprise Scheduler because it's the simplest to understand and it's the easiest to get started with. So this is the newest solution that has come out, but basically it's designed for running functions on a predefined schedule. You can think of this in seconds, in minutes, hours, or days to update and cache data in the background independently of a directed user interaction. So basically, let's say that you have an API endpoint and you want to retrieve this data and store it locally every single day. This would be a really good approach to do that. So there's a lot of other different ways that you could use it, but primarily that's what I would use this for. Is you need to have something done. You want it in local storage, which is the fastest of retrieval to your application, to your user, and you can schedule this task to happen in a defined time to your time zone. So it is the easiest to integrate as well. Whenever you create a Dash application and you're looking to deploy it, there is a proc file. So just to kind of show that, I'll pull up the workspace and we'll go into the IDE. And if you go over here, you can see that there is a proc file. So most of the proc files typically look like this. It's just one line where you're telling your GUnicorn to look for the app file to run for the server. So this is what is actually hosting your application on the backend server side. So it's basically looking for the server, which is going to be located in here. And yeah, if you scroll down, this is what it is defined. And this app.server is running your actual Dash application in production. So that's the idea, very simple, of a proc file. Now, jumping back into the documentation, the only change that we need to make whenever we are setting up a Dash scheduler is to define this dash dash preload. Once you do that, then you're going to have access to Dash scheduler within your production environment, and it's fairly simple to get started with. So there's this decorator that is called schedule, and you can see this in action, and the documentation is very well written to give a better guidance of how to set this up. But primarily in the top of your application, right after you have created your app file, right before the layout, you can throw this in here where you will create this decorator and then you will define the schedule that you want this to take a part of. So each one of these dots represent a different thing, and we'll include in the links down below some useful reference to understand what these dots mean. But basically, it's like this is the seconds, this is the minutes, this is the days, and this is what you use to define the schedule that you want this callback to take place in. So basically, it's just a function where we are getting data from a specific location, and then we are returning that data and the timestamp, as you can see here. So the pros of this type of setup is it's really simple to set up. It has reduced latency because it's storing all the data within the cache of the application, and it's easy to scale. So with that, it has real-time updates, which is good. It offers flexibility without really any constraints, and then it's time zone aware. So some of the cons for this is that it's not used for triggering long tasks, and then its memory is limited. So because you are caching within the application, huge files and systems like that, this isn't going to be ideal for. And there is no task queue resilience. What this means is that if your application crashes for whatever reason in the middle of a task, then it's not going to retain that information. You'll most likely lose that. So just things to be aware of. Now, with that, we're going to kind of talk about this second part, which is going to be a celery process with Redis. And with that, I created this little picture, which I thought was really well designed. But basically, you can think of this as the web server. You have your Plotly application over here, and then you have another web server, which is going to be used to run Celery. Okay, so within your proc file, as you recall that I mentioned, there was only one line. Within this type of development setup, over here you can kind of see it, there's going to be two lines. One is going to be running the dash application, and then the second line is specific for running the Celery worker. So with that, the way that this works is that through background callback or triggering a task, or you can have it on a schedule similar to the example that we just shown, but you can set up the Celery schedule to run at certain times. And then what this is going to do is it's going to send a message to the Redis broker. So Redis is a temporary data storage system that it has a broker transport queue, which could be defined as basically an aggregated list of tasks that are being sent to it. So it will execute these tasks in the order that they were sent. So that's what the queue is used for. Basically, what it will do is it will queue up the tasks. It will send the task as they come in through either the Plotly application or the Celery automatic tasks scheduler to the Celery web server. So this web server will return a result after it has finished its work. So this result is going to be stored in Redis temporarily, and you have two options for this. You can directly retrieve it through Plotly itself, like through a callback retrieval, or you can store this automatically to a Postgres database, which is easily integratable into Dash Enterprise. From there, you have the option of retrieving the data as it was stored after the fact into the Postgres server from your Plotly application. So that's the overview of the architecture in regards to this type of setup. It sounds complex, but it's really easy to get integrated, and I can show how to set this up. But before I do, let's talk about the benefits of this type of setup. So it was designed for handling long-running tasks that are intended by a user interaction in a Dash application. When a user triggers a callback that might take a significant amount of time, this setup offloads the process to a separate Celery worker, preventing the app from becoming unresponsive. So the pros is it handles user-triggered long-running tasks, asynchronous operations, it supports that. Scalability, it's dynamic and it's set up. You have a lot of really powerful tools that create this scope. So it supports task queuing and management so that you won't lose the tasks if your application shuts down, for example. They'll still be stored and you can still start back up. So it offers real-time updates. You can think of Redis in a way, for example, a poll, like for people voting. You can dynamically update the results of the poll with Redis and have that as a management tool. And there's a lot of different ways that it supports real-time updates, which partners well with callbacks, which support, everything that callbacks support. So it's very flexible. It's a clear separation of concerns. So where this decorator option, it's all within the same Dash application. This kind of separates things in a sense where you have a application within the proc file, and then you have a worker designated for tasks, where in the other application, it's using the same worker as the application itself to run tasks. So that distinction is better performance. So uh, it disables input during processing, so that you can't have multiple processes uh, from the same input, which is good. So some of the cons is it does increase the complexity. These are all new tools, and they all have different quirks or configurations and understanding that needs to be acquired to fully get the complete use out of them. I know that Dash Enterprise offers a lot out of the box to make it really easy to integrate into your application, which will expedite that learning curve. But there's still some understanding that is useful to know in Celery, in Redis, in Postgres. So resource overhead, there are more things running on the server that the application is running on. So you'll see, some of the stats involved with the GPU and other stuff like those will all go up. So just to be aware, if you end up setting this outside of a Dash Enterprise account, this type of setup could cost you more money. So other benefits of this setup and what is included on top of it. So refresh data periodically. So I kind of already mentioned that. Save it to a database is another useful feature. The background tasks, which we also mentioned. But one thing I didn't mention, which is really powerful, is going to be the Dash Snapshot Engine. What this allows you to do is to generate PDF reports from the app view, and then you can send these to specific email addresses. So you can generate a report that can be referred to within the application itself, or you can send it as a PDF, which a lot of enterprise customers really value. So this is used in that integration and to get those features out of it. So with that, how to set up Celery and Redis within Dash Enterprise. This is a brief overview, and there's going to be more explicit videos on this topic. For example, setting up Dash Snapshot Engine. But for this brief overview, just to kind of show you how to get this set up, what you want to do is you want to go into the settings within your workspace. As you can see here, you go to Services, and then there are two buttons. One says Add Redis, and then the other one says Add Postgres. And if you click on those, then it's going to generate it for you, and it's automatically going to put these variables in your env, which is located in your workspace. So you don't necessarily need to do much setup in regards to this, but you'll take this return and you will throw this in the application whenever you are creating it. So just reference the link that it provides, and you'll use that variable within your application. As I mentioned, this does have another line that's being used within the proc file. So you will take this line that you can see right here, and you will put it directly after your web GUnicorn app server workers. Then for the Celery and Redis, you need to add those within the requirements.txt so that you can use those within your application. The next thing that you want to do is you want to make sure that you have these imports. So these are going to be the primary ones that you're going to focus on to make sure that they're at least in your application. The next thing that you want to do is at the top of your application, there's a bit of a setup in regards of reading your environment variables, which is done through this command that you can also see was set up through this. And then what we have here is we have a setup distinction between the workspace and production. As you run your application in the workspace, the URL changes versus in production. So you want to account for that whenever you are taking in this setup. Ideally, you would want to set up a condition at the top of your application that checks for both options, and it automatically sets everything up according to, are you within the development workspace, or is this a production release? So with that, we define the Redis broker and the Redis backend URL, and then we define the Celery app, and then we define the background callback manager, and then we put that background callback manager within the app file, and then that is the initial setup that is needed to get started with this. There are more useful insights within the documentation. I'd also highly recommend looking at the background callbacks and caching because this is very useful in conjunction with both of these options. But yeah, so with that overview, this is a really powerful tool. I highly suggest using it, especially if you're working with large data sets and if you are having large load times for specific callbacks or tasks. And if you're trying to improve your user interaction and performance, this is the solution that I would start looking into. And with that, thank you, and I'll see you guys in the next one.